Welcome to Cosmic Compass, the channel where we journey beyond our world to explore the wonders of space and the mysteries written in the stars. Together, we unravel the stories of planets, moons, and cosmic phenomena that shape our universe. Today, let's turn our gaze towards Saturn's largest moon, Titan. This alien world is shrouded in haze, yet beneath its thick atmosphere lies a landscape that feels strangely familiar: rivers, lakes, and seas. But unlike Earth, these lakes are filled not with water but with liquid methane. How did such bizarre seas come to exist? And what secrets might they hold about the universe we live in? Join us as we follow the trail Cassini left behind, uncovering the strange and fascinating story of Titan's mysterious lakes. It has been years since the Cassini spacecraft ended its mission by diving into Saturn's atmosphere, yet the treasure of knowledge it left behind continues to shape our understanding of the outer solar system. Cassini was more than just a spacecraft. It was a pioneer that revealed a world unlike any other. Titan, Saturn's largest moon. Among its many discoveries, one stands out as especially strange and fascinating: the confirmation of liquid methane lakes on Titan's surface. Imagine that, for a moment, another world hundreds of millions of kilometers away, where lakes and seas shimmer not with water but with methane. But this raises a question: how did these lakes come to exist? What forces shaped them? And why did they appear so different from lakes here on Earth? In this journey, we will explore Titan step by step. Together, let's compare it to Earth, uncover what Cassini observed, and dive into the mysteries of how these alien lakes may have formed. Along the way, we'll encounter strange rivers, seas larger than the Caspian, and even evidence of explosive craters. By the end, we'll realize that Titan is not just Saturn's moon, it is one of the most Earth-like yet alien places in the entire solar system. Only two places in the solar system are known to have stable liquids on their surfaces: Earth and Titan. At first, that might make Titan sound familiar, but as we dig deeper, we find a world both similar and utterly alien. Earth is a rocky planet with a dense iron core and a silicate mantle. Titan, on the other hand, is a frozen world. Its crust and mantle are made mostly of water ice, with a subsurface ocean hidden beneath. Because of this difference, Earth is far denser. Its larger size and stronger gravity also shape its atmosphere differently. Earth's air clings tightly to the surface, while Titan's thicker atmosphere stretches hundreds of kilometers above the ground. Now let's consider temperature. Earth is close enough to the sun for water to remain liquid and to drive a vibrant water cycle. Titan, much colder and farther from the sun, has water locked in solid ice. But here's the twist. Titan's frigid climate is perfect for liquid methane. Just as Earth has a water cycle, Titan has a methane cycle with clouds, rainfall, rivers, and lakes. It is like looking into a mirror, but through that mirror, the reflection shows a completely different world. Cassini revealed a breathtaking reality. Titan's methane does not just exist in the air, but actively shapes the surface. Methane clouds condense rainfalls, and rivers carve valleys through the icy crust, eventually flowing into seas. Radar images from Cassini show vast riverbeds and canyons. One striking example is the network around Ligaea Mare, Titan's second largest sea. These channels, named Vid Flumina, are ancient. Their canyon walls tower hundreds of meters high, steep and imposing. Though methane no longer flows freely, there parts of the valleys remain filled, drowned by the rising level of the sea. But Titan's lakes go far beyond rivers. The largest Kraken mare covers about 400,000 square kilometers, bigger than Earth's Caspian Sea. Cassini's data suggest that while some lakes are shallow, no deeper than a swimming pool, others plunge more than 200 meters. Altogether, Titan holds a staggering reserve of hydrocarbons. In fact, Scientists estimate that Titan may contain over 300 times the amount of fossil fuels ever discovered on Earth, and yet despite their vastness, these seas are strangely quiet. When Cassini flew overhead, it saw no waves higher than a single millimetre. Imagine flying above a sea larger than the Caspian, only to find its surface smooth as glass. Why would such alien oceans remain so perfectly still? Here is where Titan surprises us again. With its thick atmosphere and low gravity, scientists expected strong winds to whip across the lakes, raising waves as tall as a metre. Instead, the lakes appeared calm, too calm. Several explanations have been proposed. Perhaps Cassini passed overhead during an unusually windless period, or maybe Titan's lakes are thicker, more viscous than we expect, making wave formation more difficult. Another possibility is that the lakes occasionally freeze, their icy crust keeping the methane still. A more recent idea is even stranger. Dense aerosols in Titan's atmosphere might settle on the lakes, forming a thin surface film that damps any wave activity. Whatever the cause, the image remains unforgettable. Imagine standing on the shore of Titan, staring at a methane sea that reflects the horizon like a perfect mirror, a silent alien ocean, motionless under an orange sky. If Titan's surface is shrouded in a thick orange haze, how did Cassini reveal such detail? The answer lies in the power of radar and infrared imaging. Cassini's radar mapped Titan by sending radio waves through the haze and measuring the echoes. Large dark patches on these radar maps first hinted at the presence of lakes. To confirm, scientists turned to Cassini's infrared camera. Here, sunlight reflected off Titan's surface in what is known as specular reflection. When the light bounced off a perfectly flat surface such as a lake, it created a bright, unmistakable signature. This technique became essential, used repeatedly to confirm radar data. Even more fascinating, Cassini could spot changes over time. One year, an area appeared bright, dry and solid. A year later, the same region showed darker patches, evidence of shallow lakes formed after rainfall. For the first time, we were not just looking at frozen landscapes, but witnessing Titan's methane weather in action. Titan's lakes are not spread evenly across the moon. Most cluster near the poles, while the equator appears relatively dry. Yet Cassini's partner, the Huygens probe, landed near the equator and found evidence of dry river channels. So what happened to the lakes that once filled them? The answer may lie in Titan's seasons. Just as Earth's weather changes with time of year, Titan too experiences seasonal cycles. When rain falls near the equator, lakes may temporarily form. But as the seasons shift, these shallow lakes evaporate and rainfall migrates toward the poles. Here's the catch: Cassini orbited Saturn for 13 years, but that's less than half of one Saturnian year. A single year on Saturn lasts nearly 30 Earth years, meaning Cassini observed less than half a Titanian climate cycle. So the truth is, what we saw may only represent a small slice of Titan's changing climate. Lakes may rise and vanish, rivers may flow only once every few decades. In many ways, Titan is still holding its secrets close, waiting for us to watch a little longer. One of the strangest puzzles from Cassini's data involves Titan's smaller lakes. Some of them have steep rims rising above the lake level, unlike anything seen on Earth. On our planet, lakes typically form through erosion, glaciers, or dissolving limestone, which leaves shallow, smooth basins. Titan's sharp-edged craters did not fit, so what carved them, scientists now suspect these are explosion craters. Long ago, Titan may have been colder, with nitrogen falling as rain or snow. This nitrogen seeped into the icy crust, collecting underground. Later, cryovolcanoes pumped methane into the atmosphere, warming the moon. As Titan warmed, the buried nitrogen began to evaporate, expanding beneath the surface. The pressure built until finally the ground above gave way in a violent release. The explosion blasted open a crater, which over time filled with methane, creating the steep-walled lakes we see today. Imagine the scene: Titan's surface trembling, a sudden eruption beneath the ice, a blast carving out a hole that would one day become a mirror-like lake. It is geology written in slow motion across an alien moon. What Cassini uncovered on Titan was more than a collection of lakes. It was a story of cycles, seasons, and violent changes written in methane instead of water. These discoveries show us how diverse planetary bodies can be, even within our own solar system. They also remind us that Cassini's legacy is far from over. The data it sent back will continue to inspire research for decades. Titan remains a world of mystery. Each lake, each cloud, each river valley points to processes we are only beginning to understand. And perhaps most importantly, Titan hints at what other worlds might hold. If a moon of Saturn can sustain lakes, rivers, and weather, what might we find farther out on worlds we have yet to explore? Cassini's mission ended, but its discoveries live on. Titan continues to whisper secrets across the void, waiting for us to return. If you enjoyed this journey, let's keep exploring together. Subscribe to Cosmic Compass and join us as we uncover the mysteries of the cosmos one story at a time. And now the question is left to you. When we finally return to Titan, what will we discover next? That was our journey into Titan's methane seas, a world so distant yet so eerily Earth-like. The story of Titan reminds us how diverse and dynamic the cosmos truly is and how much is still left to discover. If you enjoyed this exploration, make sure to subscribe to Cosmic Compass for more voyages into the unknown. Together, let's keep asking questions, following the clues, and uncovering the hidden wonders of our universe. Until next time, keep looking up, and let's continue to explore the cosmos, one story at a time.